Hey guys, Coach here. Today we're going to be going over the intro to algebraic reasoning. So this is one of our early lessons and it goes over this concept of algebra that so many people find scary, but it's honestly not. It's just the unknown, but it's the first step in math where we really are combining these letters with our numbers, and that throws people off and it's like, why are you doing this? But it's like any other play that you might run in football or basketball where we've got X's and O's. If I was running a basketball play, here's my court. Let's say I'm like, okay, I'm going to put my wing out here. I'm going to post up here. And then I'm going to have my flex coming from all the way down here. Well, these X's, what do they mean? Those are my players. I'm just using these X's instead of my players. Well, in math, we're doing the same thing. We're using things like X's or Y's, or these letters, instead of numbers in certain times, just like when we draw up a play. So we're going to go over that. We've got 6 questions we're going to work through in this video. And then you've got a 4-question quiz that you can do on your own afterwards. If you haven't already, in the lesson there is a downloadable sheet, which is this exact one I'm working off of. So we're going to be doing these questions together. If you rather just do it on your own sheet of paper and draw it out, that's fine. That's cool. Don't bother with writing out the actual questions. You can just write out the problems as we're doing it. So let's get into it and look at this concept of algebra. Algebra just means the unknown. What do we not know? What are we looking for? Well, let's look at our first question. It says triangle perimeter. A triangle has 3 sides with the following lengths: 2x plus 1 units, 3x plus 5 units, and 4x minus 1 units. Now, we got these word units, and we don't know what units means. It could be inches, it could be miles, it could be feet. I don't care, okay? It really doesn't matter to us. What we need are these expressions, and that's what we call them. We call them expressions. And you'll notice, in this it says, write an algebraic expression. It says, write the expression. And nowhere do I see the word solve. And we love it when we don't see the word solve, because that means we're not actually calculating anything. There's no numbers really to figure out. We're just writing out what it would be. So let's look at our triangle. Now I'm just going to sketch out a triangle so I can kind of picture this out. My triangle doesn't have to be perfect. Go ahead and draw out your own triangle if you want to. And I got 3 sides, and technically for what we're doing on this part, it doesn't matter what side is which. I'm just going to now label each side. So my first set is 2x plus 1. So I'll just pick this side, 2x plus 1. So this side over here is 2x plus 1. The next section, it's 3x plus 5. So I'll stick that over here, 3x plus 5. A little long leg there. And then it leaves me the third side, and it says 4x minus 1. All right, so I've got the concept. You can see it, right? What do I notice here? Everything is either this x value, I've got like a number with an x, or I've got just a regular old plain Jane number. And that's good, because this is most of the work. Right now, this is not wrong. It's just not done yet. We're so close, because we want to combine like terms. Fancy way of saying stick the stuff together that goes together. Okay, so I've got, you'll notice the variables. I got 2x, I got a 3x, and I got a 4x. Well, if I'm looking for the perimeter, perimeter means my distance around the outer edge, right? And this isn't supposed to be a geometry lesson, but we got the idea. So I'm going to combine those things because they're all in increments of x. So 2x plus 3x is 5x. Plus 4x is, well, 2 plus 3 is 5 plus 4 is 9. I had to slow myself down so I didn't go too fast there. I got 9x. But now I've got these whole numbers. I got a plus 1, a plus 5, and a minus 1. So 1 plus 5 gives me 6, but now I got a minus 1, so I'm back down to 5. But this 5 is a positive. And that's it. because we didn't get asked to solve, and technically we can't solve anymore. This is as far as we can go on this particular problem because we don't know what x is. So our final answer is 9x plus 5 units. That represents, if I add up this side of the triangle plus this side plus this side, that is my perimeter. And that's all I got to do. I'm just adding those three together or combining them. I probably shouldn't use the word add. All right, so that's our first example. Let's go to our second example, which is number 2. Slide it on up here. If you didn't print it out, that's fine because I'll be going over the things here and you can see it in the corner. All right, so now rectangular area. The length of a rectangle is 3y minus 2 meters. And the width is y plus 4 meters. Solve for the area of the rectangle when y equals 2. Okay, now we do have this word solve. And we've got a lot of steps here. We got all these little expressions. This is algebra simply because we have a variable. We got this letter stuck in here. And we don't know what it is at first. At the end here, you'll notice it tells us what the y is. So let's go ahead and draw this out. And if you don't want to, just watch me as I draw a terrible picture. All right, so here's my rectangle. It says the length of the rectangle is 3y minus 2. So I've got 3y minus 2. And the width is y plus 4. So I got y plus 4. Now, I could have labeled it either side because it doesn't matter. Now it wants me to solve for the area. Now, when you actually take your GED test, if this is the question, remember, on your GED, you're given a formula sheet. It will be a laminated sheet, regular size sheet of paper, and in there, it gives you this formula. Well, area of a rectangle, it's the simple one. It is length times width. And what was my length? Well, here's my length, here's my width. But coach, can we even go any further because we don't have the y? We can't multiply when it's like that. Well, kinda. Because down here it tells us y equals 2. So I can now substitute in my 2. So I'm gonna now change this up. This is 3 times 2 minus 2. And you know, sometimes they'll write the multiply with the little dot in between there because that's kind of like the higher step. A lot of people are so used to seeing it with the X, and even on the calculator it's shown with the X. But sometimes you'll see people write it with a little dot because the X is actually our most popular variable. It's used a ton. So sometimes you'll see it written with the little dot. So 3 times 2 is 6. 6 minus 2 is 4. So now I know that my length equals 4. And what did I do? I just took the value of my y that it told me, and I plugged it in. Got to do the same thing with my width. Well, y equals 2, so I can put instead of the y, put my 2 plus 4. And you can see the math isn't hard on this part. And of course, this would be one of the sections that you can use the calculator on. It's like, well, I don't really need the calculator for 2 plus 4. It's 6. Yeah, exactly. So now I know my width equals 6. And so my formula is length times width. And there I use the x again, even though you can see now why we start to move away from using the x, because LXW is like times. Is it a variable? Yeah. So you can see why a lot of times we'll move away from using the x. Sometimes you'll even see them just whenever you have two variables side by side. They'll just put it LW, and it's assumed whenever you have two variables, it's always assumed that you're multiplying. But anyways, we've got our value of 4, and we got our value of 6. So 6 times 4 gives us 24. Am I done? Because I'm not wrong. 24 is not wrong, okay? It's just not done yet. This is running 99 yards, and we still got to get into the end zone. All right. Because over here it tells us meters. it's in meters. So I know this is 24 meters. Except, do you remember whenever we're dealing with area? Because we have two dimensions, we have a length, here's our first dimension, and a width, there's our second dimension. 2D, length and width, 24 meters squared. We put the little 2 above it because that's our squared symbol. And literally, what does that mean? It means it's squared. If I took this rectangle and filled it with a whole bunch of squares that were 1 meter by 1 meter, I could stick 24 of them in there. Like 24 itty bitty squares. Now, my drawing's terrible, but you get the idea. You can stick 24 in there. But cool. And those two really represent the biggest foundation for all your algebraic reasoning on your GED test. Now, it can be shown to you a whole bunch of different ways, and I can't possibly show you every way they can show you, but I can show you the most common. Those two are super common. Let's work through a couple more. Okay. Now, last two had to do with like what's called spatial reasoning, fancy word for shapes or how does it look. This is concept, shopping budget. Sarah buys X notebooks for $5 each and Y pens for $3 each. How $5 notebooks? Man, I go to the dollar store for these things, man. Y pens for $3. $3 pen? That better be a nice pen. I don't know about you. I always just like get a pen from like the doctor's office or something, or the bank if it doesn't have a chain on it. Anyways, I digress. Write an algebraic expression for the total cost of Sarah's purchase. Oh, once again, it says write the expression. You know what word I don't see? I don't see the word solve. So since I don't see that word solve, it means just looking to write it out. Don't need to actually work the numbers like I did in the last one. So Sarah buys X notebooks. I don't know how many. It's just written with an X. And how much are those notebooks? $5. So however many notebooks she buys, she's paying $5 each. Variable next to the number, it's assumed to be times, and you can see why we wouldn't use the X for the times here because it's just variable next to the number. You could put the dot in there, and the dot would always go halfway up because if you put it at the bottom, it makes it look like a decimal. And so this is why as you get further along in math, you kind of move away from the dot too, and you only use the variable next to a number. I digress. Side note. Back to here. So that's X notebooks for $5, and then Y pens for $3. So if I want to know the total cost, I see this word total. What process? What math thing am I going to do? The step. What do you got? It's adding. So I'm adding it together. And that's it. This one's actually completely done. There is no actual math in here. This is just reading the problem and can you find the correct expression for it? However many notebooks I buy, X, it's $5 each. However many pens I buy, Y, they're $3 each. Now, sometimes they might tell you how many they buy and what the value is for X and Y, but that's not the point of this one. This one is just write the algebraic expression, and we just wrote it. So 5x plus 3y. Done. Capiche? All right, let's get these last few done, and you'll be ready to move on. All right, I'm flipping over the back. And, I don't like how that looks like. You can see some of the words on the underside. I'm going to move that out of the way. There we go. That's yuck. Yeah. Maybe if I do it like that, that's a little better. Okay. Sorry, Coach gets a little particular about how he does stuff. All right. All right, garden fencing. This one probably should look familiar. A rectangular garden, rectangle, I know what that is, has a length of 2a plus 7 feet and a width of a minus 3 feet. Come on. Keep focused, phone. Write an algebraic expression for the perimeter of the garden in feet. Algebraic expression. I don't have to solve. I'm just writing it out. How would I write out the expression to solve it all if I did have it? Well, this is one example where it's real easy to try to do it in your head, but use you're going to get a spiral bound notebook, like a little, and it's going to be slick paper on the GED. It's like a plasticky whiteboard paper, and you're going to have a whiteboard marker. And so you're going to want to draw it out. In fact, it even comes with grid on there. So I'm going to draw out, yoink, my rectangle. All right, length, 2a plus 7. So here's 2a plus 7. My width, a minus 3. A minus 3, right? Well, don't I just add those sides? Aren't I done? Well, that's not wrong. It's just not done. Because when we're talking perimeter, because it says down here, look at this time. On our last time we asked for perimeter, it was really early in the question. This time they put the word perimeter towards the bottom of the question. Perimeter is all 4 sides. Well, the side down here, this is also 2a plus 7. And the side over here is still a minus 3. To find the perimeter, I got to add up all 4 of these sides. Now, I could get fancy and like do this side, multiply by 2's, blah, blah, blah. Don't do that little BS stuff, okay? This is simple. Keep it simple. Keep it simple. We got 4 sides. Let's add them up. First off, you'll notice all these are in terms of a. I don't have another variable like a b or an x or a y or something. Combine my like terms. We said that earlier. Combine like terms. Well, I've got 2a plus an a here. That's 3a. Then I've got 2 more a down here, 4, 5, plus an a over here. That's 6. So I've got 6a. But coach, isn't that a minus sign? You're right, this is a minus sign, but that minus, the sign always goes with whatever's after it, okay? The minus is going with the 3 in this case. Because the a, it's got the 2 here and the a is by itself, there's no plus or minus. Whenever there's no sign, we always assume it to be positive. We only use a special sign if something's negative or if we're taking it away. All right, so now I've got my whole numbers. I've got a 7 and a 7, so 7 plus 7. So really I've got 7 plus 7, that's this one, and that's this one. Now I got a minus 3 here, minus 3, and I got a minus 3. All right, let's do it. 7 plus 7 is 14. So now I got 14 minus 3, minus 3. 14 minus 3 is 11, minus 3. 11 minus 3 is what? That's 8. But is that a minus 8 or plus 8? Well, 11 is positive minus 3, so we're still at a positive 8. So 6a plus 8. So looking for my perimeter, 6a plus 8. The biggest mix-up you do on this one is you forget to do all 4 sides. I've seen it so many times where we forget to add all the signs on these perimeter questions. And make no mistake, perimeter is definitely going to be in there somewhere. There's going to be some kind of perimeter question in there. All right, 2 more. 2 more. And I'm going to give you a chance to kind of do this on your own. I'm going to help you set it up and let you try 5 and 6 on your own first. But I'm going to make you do work by having you hit the pause button at certain points. All right, savings plan. We're going to be using the same thing. It's still algebraic reasoning, except we're just talking about money now. John saves B dollars every week for 4 weeks. Okay, so B dollars. He saves some money every week for 4 weeks. And his friend saves 2B plus $5 every week for 3 weeks. Okay, so dude saves a little bit more. Write an algebraic expression for the total amount saved by John and his friend. Okay, if you're totally lost and you're having a brain fart, something's not clicking for you when you do the test, you can literally write out every single part. For instance, John saves B dollars every week for 4 weeks. Okay, week 1, he saves B. Week 2, he saves B. Week 3, he saves B. Week 4, he saves B. So 1, 2, 3, 4. So after 4 weeks, he saved 4B. Now, we don't know how much B is because it said write the expression. It did not say solve. Because it did not say solve, we're not actually calculating, we're not looking for a single number as our answer. Now, his buddy, for 3 weeks, saved 2B plus 5. So his buddy had 2B plus 5. That's 1 week. Next week, it was 2B plus 5. And on the 3rd week, he saved 2B plus 5. So if I add all those together, 5 plus 5 plus 5 is $15 here. 2, 4, 6B. 6B plus 15. So his buddy saved 6B plus 15. So now it's looking for the total amount saved by John and his friend. Would I add the 4B to the 15 or the 6B? This is where I'm going to pause, and you can pause it here too. Figure out what your final answer would be. Waiting for pause. You're looking for the pause button. Now you found the pause button and you unpaused it because you think you found it, and I'm just killing time for a second. Blah, blah, blah. How you doing? It's snowing today. Hope you're having a nice day out there. Okay. So this, we now just are going to combine alike terms. Well, because the terms have variables, the 4B and the 6B, those are where they're combined. I've got to combine these two because they're the ones that are alike. They have the variables. So 6 plus 4 is 10B. But I still have this 15, so I got to add in that 15 at the end. 10B plus 15. Now you might be going, well, Coach, do I have to write it out? Because I can see, I said it's 4 weeks at B. I know that's 4B. And then I know it's 2B plus 5. So I know he's doing it, 3 weeks. He's saving 2B plus 5. Yeah, if you're comfortable with this algebra way, you could do it this way. Watch, you're going to get the exact same answer. It's just kind of messier. I guess maybe it's not any more messier than this. But this is our final answer. And we got 10B plus 15 from writing it all out. And I love the method when you're having a brain fart, when something's going on, because you're going to be nervous. Your nose is going to be running. You're going to have to go to the bathroom, and you can't go to the bathroom during certain points during the test. You only can go during the special break parts. Sometimes your brain ain't working right. So do the old school way. Write it out. Just like up here where we drew the stuff out. It works. There's a reason these pictures and stuff work, and we don't change it. It's been working for thousands and thousands of years. There ain't no reason to change it now. But you can't do it this way. We can distribute this 3, and this isn't a lesson on distribution property, but some of you might recognize this. The 3 goes to here. 3 times 2 is 6B. But then because it's on the outside of the parentheses, I also got to distribute the 3 to the 5. That's plus 3 times 5 is 15. Bring down what I haven't used. 4B plus 6B plus 15. Well, 4 and 6, that's 10B plus 15. Honestly, on sometimes when I'm thinking out these problems, I really do prefer this method just because it forces me to think out step by step. This does work, don't get me wrong. And sometimes it might be easier for you. Great, go for it. If it ain't broken, don't fix it. Go with what works for you. All right, last one, and then I'm going to turn you loose and let you try your own quiz set. And another one they love on the GED. They love speed questions. For some reason, there's always some kind of speed equation, or I've seen sometimes they might use like miles per gallon, something like that, like unit rates are big. So we're going to get into this one, use speed as an example. A car travels at a speed of 60 miles per hour for T hours. Okay, T hours. And then at 80 miles per hour for 2T minus 1 hours. Don't ask me where they got 2T minus 1 hours. It's just, it's part of the question. Don't try to overcomplicate and be like, oh, how are you getting the minus 1? No. They went 80 miles an hour for this long. 60 miles an hour for this long. Write an algebraic expression for the total distance traveled by the car in miles. Okay, so I'm writing the algebraic expression for the total distance traveled. I can't solve for the total distance because I don't know what t is. If they don't give me t, since t is unknown, I can only set up the expression, I can't solve it. But I can write how I would solve it, that if they ever told me what t is, I could figure it out. So I have 60 miles an hour for t hours. So like if how many hours t was, I was doing it for 60. Then I had another set that I was driving, so I'm going to add it because this is my other section of the trip. I was going 80 miles per hour for 2t minus 1 hour. 2t minus 1. Oops, hold on. I should have stuck in my 80 first. So I was going my 80 miles an hour. Now we're going to add something called parentheses. We're going to put this in here for 2t minus 1 hours. It don't look pretty right now. This is not wrong. If you got this far, you are like 75% of the way done, and it is completely right. But just like I was talking about with the distribution up here, that's something we're going to have to do here. Because this one, it's not as easy. We don't have like the exact number of things that we can draw out. It's not like up here where we knew it was 3 times this time. So I'm going to have you hit pause. Try to come up with the final answer on your own. It's going to be an expression. It's going to look a little ugly. I'll tell you that right now. It's not really pretty. But you can figure it out. All right, so I'm guessing you've unpaused at this point, or you didn't even bother. You're just going to let me show it to you because, let's be honest, a bunch of you did that. 60t. There's nothing I can do here. That's just by itself. It's all done. But I can distribute this 80 because it's on the outside of the parentheses. This 80 is affecting my 2t, and it's affecting my minus 1. So I'm first going to distribute the 80 to the 2t, then the 80 is going to affect the minus 1. Now, a number outside the variable, we always assume that to be multiplication. So 80 times 2. Well, 8 times 2 is 16. So 80 times 2 is 160. Oh, but it is t. We still don't know what t is. We just know that we did 160 of whatever this unit t is. Now, 80 times my minus 1. Well, 80 times 1 is 80 minus 80. Well, wait a second, Coach. Why is it minus 80? Well, you're multiplying times a negative. 80 times negative 1 gives you negative 80. Now, I still have this 60t. And this plus, those haven't been touched yet. They're just by themselves. 60t plus 160t minus 80. I am not wrong. I am not wrong. In fact, if you got this, kick butt. You did awesome. One more step. There's one more little thing you can combine. There's one more little piece you can do. And if you're doing this on the test and you get this far, and this answer is not one of your answer choices, look at your answer choices and see, oh, what kind of looks similar? And see if there's something that can trigger you. In this case, I have 60t plus 160t. These two are like terms. We are going to combine them because they're the same terms. They're both units of t. 60 plus 160, that's 200. 20, or 16 plus 6 is 22. And you can punch that into your calculator if you're doing it on the test so you don't accidentally mix it up. That's a totally do it. Don't, because once again, your brain might not be working right. So punch that into the calculator. It's units of t. And then I bring down this minus 80 because I haven't done anything else. There's no other whole numbers to combine. Minus 80 is by itself. And now Now I have a completed problem. All right, guys, 30 minutes to get through algebraic reasoning. We just did 6 problems. You may not have needed that whole time. Hopefully this was a great review and reminder. There is a quiz, and the quiz has 4 problems. I'm going to let you get those done on your own. If the quiz gives you fits, if you're like, oh, I'm totally lost, I'm going to have a separate video on there that you can load, that you can play, that's going to have the answers to the quiz. Then I'm going to work out those 4 problems. But I think you're going to be okay. All right, guys. Kick butt. This is Coach signing off, and we will see you next time. You got this.